Welcome to the world of retail and e-commerce analytics. In this presentation, we will explore how data analysis can transform your business. We will focus on three core pillars of modern retail analytics: customer analytics, inventory management, and personalization at scale. Let's start with customer analytics. Customer analytics is the systematic analysis of customer data to understand behavior patterns, preferences, and value contribution to business growth. It transforms raw customer interactions into actionable business insights. The core benefits of using customer analytics include increased customer retention and loyalty, higher revenue per customer, data-driven marketing decisions, and reduced customer acquisition costs. Next up are the customer segmentation techniques. Here we can look at two primary ways to segment customers. The first way to segment the customers is through RFM analysis. RFM stands for recency, frequency, and monetary. Recency is the last purchase date, frequency is the purchase frequency, and monetary is the total spend amount. Using these three factors, you can segment customers. The code snippet shows how you can create an RFM score using pandas. The other method is behavioral segmentation. In behavioral segmentation, we use categories like champions, which are the best customers, loyal customers who are regular buyers, potential loyalists who are recent buyers, at-risk customers who have declining engagement, and hibernating customers who are inactive. The next important concept is customer lifetime value. Customer lifetime value is equal to the average order value multiplied by the purchase frequency, multiplied by the gross margin, multiplied by the lifespan in months. This calculation helps you to predict customer value. Here's a look at the Python implementation. First, define a function, calculate CLV, passing in customer data. Average order value is the total spent divided by the number of orders. Frequency is the number of orders divided by the number of months. Gross margin is 0.25, that is 25% margin, and lifespan is the number of months. The customer lifetime value is the average order value multiplied by frequency, multiplied by the gross margin, multiplied by the lifespan. Finally, apply this to customer segments. Next, let's dive into inventory management analytics. Key metrics to consider are inventory turnover, which is calculated by dividing the cost of goods sold by the average inventory. Days sales outstanding, which is calculated by dividing average inventory by daily sales. Stockout rate, which is stockout days divided by total days, and carrying cost, which is storage plus insurance plus opportunity cost. For demand forecasting, we can predict future demand using historical sales data, seasonality patterns, and external factors for optimal stock levels. The code snippet is a simple demand forecasting model using linear regression. We import linear regression from scikit-learn and pandas. The function forecast demand takes in sales data. X is sales data with the month and seasonality. Y is sales data with the demand. Then we create a linear regression model, fit the X and Y values and return model, predict with the next period's values. Let's explore the ABC analysis and safety stock methods. For ABC classification, we can divide products into three categories. A high-value items, which are 20% of the items and 80% of the revenue. For these, we need tight control. B, medium-value items, which are 30% of items and 15% of revenue. For these, we need moderate control. And C, low-value items, which are 50% of items and 5% of revenue, so basic control is needed for these. Safety stock is buffer inventory to prevent stockouts during demand or supply variability periods. Safety stock is equal to Z multiplied by sigma multiplied by the square root of LT. Here's an example implementation in Python. Import number per y is np. Define a function, calculate safety stock with demand standard deviation, lead time, and service level as parameters. Z-score is equal to 1.65, that is 95% service level. Safety stock is Z-score multiplied by demand standard deviation multiplied by number pot square root of lead time, and return safety stock. Let's discuss personalization at scale. What is personalization? It is delivering customized experiences to individual users based on their preferences, behavior, and context. The key benefits are increased conversion rates, enhanced customer satisfaction, higher customer retention, and improved average order value. Some recommendation approaches are collaborative filtering, which gives recommendations based on similar user preferences and behaviors. Content-based suggestions, which are based on item features and user profile matching. And hybrid systems, which combine multiple approaches for better accuracy and coverage. Now let's focus on collaborative filtering. There are two primary types of collaborative filtering. The first type is user-based filtering. We find users with similar preferences and recommend items they liked. Here's the Python code to do that. From scikit-learn.matrix.pairwise, import cosine similarity. Then define a function user-based recommend, passing in the user ID and user matrix. Calculate the similarity using cosine similarity on the user matrix. Then, find similar users by sorting the similarity scores for the user ID and slicing the last 5. The recommendations can be built by iterating through each user and similar users, finding the user items purchased by each similar user, and adding it to a list of recommendations. Then return the first 10 recommendations. The second type of collaborative filtering is item-based filtering. It recommends items similar to those the user has already purchased. Again, import numberwise np. Then define a function item-based recommend, passing in user ID and item matrix. The user items is equal to get user items for that user ID. Calculate the similarity using cosine similarity on the item matrix. The scores are number_of similarity and user items. The recommendations are number_py.arc sort of scores in the last 10. Return those recommendations. Next is content-based recommendations. For content-based recommendations, you need to extract the key features. Analyze item attributes to build user preference profiles. Key feature extraction methods include product categories and tags, price range preferences, brand and quality ratings, user interaction patterns, seasonal and trend factors. For similarity matching, we calculate similarity scores between user profile and items. Here's a sample implementation. From scikit-learn.featureextraction.txt, import tfid vectorizer. From scikit-learn.matrix.pairwise, import cosine similarity. Then define a function content-based recommend, passing in the user profile and items. Vectorizer is tfid vectorizer. Item features is vectorizer.fit_transform on item's description. User vector is vectorizer.transform passing in the user profile. Calculate the similarity using cosine similarity, passing in the user vector and item features. Recommendations are the similarity with the first item arc sorted and the last 10. Return the recommendations. Finally, let's consider real-time analytics implementation. Here's the system architecture that is required. First, we need data ingestion. Apache Kafka is used for streaming events. Then there is stream processing. Apache Spark is used for real-time analytics. Then there is data storage. Redis is used for fast lookup caching. And finally, machine learning models. TensorFlow serving is used for predictions. Here are some of the scaling considerations that you need to keep in mind. You need to handle millions of events per second with distributed processing and model serving. Here's some example Python code. Import Redis. From Kafka, import Kafka consumer. Define a function process user event, passing in the event. Redis client is redis.redis. Then update user profile in real time. User profile is Redis client.get user event user ID. Updated profile is update profile user profile event. Redis client.set user event user ID updated profile. Finally, generate instant recommendations. Recommendations are model.predict updated profile and return the recommendations. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.